Section 11.7, geometric probability. Here's kind of a little fun way to introduce this, maybe connected to some things you know. At this pizza place, you can play pizza roulette, and if you ask nicely, they'll put the hottest chili known to mankind on one slice of the pizza. So if you and 7 friends share this pizza, what is the probability that you will get the slice with the ghost chili? Well, the probability is 1 in 8, because there's one piece that has a ghost chili on it, and there are 8 slices total. So we can look at probability. Geometric probability is just like probability in general. It just has to do with areas of a region. And so we're looking at what is the probability that you would get this slice compared to the whole area, and assuming the pieces are cut equally, then you would have a 1 in 8 chance of getting the ghost chili. Now, we can talk about probability as far as a fraction, or you can put it in terms of a decimal or a percent. And 1/8 as a decimal is 0.125, or we can say 12.5% chance that you have. So, geometric probability has to do with areas and lengths of things. So we're going to work on finding some geometric probabilities. So probability is the likelihood that an event will happen. So when you're asked about the probability of something happening, you want it to be a favorable outcome. You want it to happen. So what's the probability that it happens? Geometric probability is the probability that includes a geometric measure like area or length. So that's what makes it slightly different, but if you understand probability in general, then this should be fairly straightforward. We're just going to be using areas and writing ratios and then dividing. So when thinking about areas and the probability that something will land in a certain spot of a geometric region, we're going to use the following formulas. So we're always going to take the area of the shaded region compared to the total area. And the shaded region is where you want it to land. Or that's your favorable outcome. And the total area is just every place that it could possibly land. We also can look at, in terms of lengths of segments, we could look at the length of the part compared to the length of the whole. So those are basically the two formulas you have. It's just that if you're finding a circular region, your area is going to be pi r squared. If you're finding a regular polygon region, it's going to be 1/2 the apothem times the perimeter, etc. So we're going to use all of the formulas that we worked on in chapter 11 and previously to actually write that ratio and determine the probability. So, for example, this is a pretty simple one. It says, if you throw a dart at this shape, what is the probability that your dart lands in the non-shaded space? So we have to find the area of this non-shaded space. So that's where we want it to land. We want our dart to land there. That's like at a carnival game, that's where you win the prize or the best prize. Okay, so we're going to take the probability of the non-shaded area divided by the total area. Well, the non-shaded area is just 9/13 rectangle or parallelogram, and then the total area would be 9 times 15. So when we divide that, we get 0.20. You could give this as a fraction, but most of the time I feel like with probability, because of areas, you're not going to have nice fractions. They're going to not be as meaningful as writing it as a decimal or a percent. The fraction would be like 27/135. But you could really list it anyway if it doesn't specify. And 27/135 actually reduces to 1/5. All right, so why don't you try this one? If you throw a dart at this shape, what is the probability that your dart lands in the shaded space? So how are you going to find that? Why don't you see if you can set it up and then turn the video back on and see if you did it correctly. So in order to get this shaded space right here, okay, we're going to have to, for the shaded area, we're going to have to take the area of the square and subtract the area of the circle. That's how we're going to find the shaded space. And then we're going to divide that by the total area. So the square is 10 by 10, or 100, and the circle has a diameter going across of 10, so that means the radius is 5, so that is going to be pi times 5 squared, and then the total area is the area of the square 100. So again, dividing that out, that gives you approximately 0.2146, which would also be like 21.45% roughly. So, geometric probability. Let's do a line segment one. I'll do one of these, or two of these, and then you do the last one. Some people get kind of confused on these, but it's really not that difficult. So, find the following probabilities of choosing a random point on AD. So if you just kind of randomly choose a point, what is the probability that it lands on BC? That's what we're looking at. We want to know what's the probability that it lands in this region right here. Well, that length is 5 compared to the whole length, which is 6 and 5 and 3 added together is 14. So the probability is 5/14, or approximately 0.36. What's the probability that it lands on CD? Well, that is 3. So you have 3 over 14. And again, you could get a decimal, but if it doesn't specify, you could just stop there. And now you try, what is the probability that it lands on AC? So this whole region. And that would be 11/14. Okay. So now we get a little bit more complicated ones, but they're really not bad. I know that you can do these. So it says, suppose the 3 circles on the target had radii of 4 inches. So we have a radius of 4 inches, and we have a radius of 12 inches, and we have a radius of 20 inches. Okay, so if you choose a random point on the target, what's the probability of hitting the red region? Well, where we want it to land, that area of the red, so we have the red area divided by the total area. Well, the red area, that has a radius of 4, so it's pi times 4 squared divided by the total area, which is 20, a radius of 20, so you got pi times 20 squared. And by the way, your pi's cancel out here. You don't even have to factor them in. So you get 16 over 400, or again, just use your calculator. You can get a decimal point, 0.04. The blue region, you try that one. That's going to be trickier because you're going to have to subtract out the area that you are not having. But check back to the notes and see if you got it right. That leads into what we're going to do here. So if you don't get it, you could watch the rest of the video and then try it. So we're going to do some a little bit more difficult shaded region ones where we might have to use trig ratios and so forth again. So if you throw a dart at this shape, what is the probability that your dart lands in the shaded space? Well, again, the shaded space right here, in order to find that shaded, we're going to have to find the area of the circle and subtract the area of the square. Well, the circle is easy. It is a radius, since this is a diameter going across, the radius of your circle is 4, so you get pi times 4 squared. Now we have to find the area of this square. So what we need for that is we need to know how long is this side and this side. Okay? Well, if you take the 2 radii right here, this is also 4, you actually have a 90-degree angle here because of these triangles inside. The 4 triangles, 360 divided by 4 would give you 90 there. So you can actually just use the Pythagorean theorem. 4 squared plus 4 squared equals that side length squared. We'll just call it x squared. So we get x is equal to the square root of 32. So now we have the side lengths being the square root of 32. So that square, the area, is the square root of 32 times the square root of 32, which is just 32. And then we're going to divide that by the total area, which is the circle, which is, the circle has a radius of 4, so it is pi times 4 squared. Again, doing that on your calculator, by the way, can be tricky because if you entered it as is, you would need parentheses around that. So be careful, make sure you're calculating these out, make sure you're not just making simple calculator errors. So then we should get approximately 0.363 or 36.3%. Okay, see if you can set this one up. It says, if you throw a dart at this shape, what is the probability that your dart lands in the shaded space? It's very similar to the one we just did. See if you can set it up and see how far you can get. Pause the video and then start again. Start the video again and work through the rest. So to find the shaded area, we have to take the area of the circle and subtract the area of a 1, 2, 3, 4, 5 hexagon. Pretty sick looking hexagon there, but anyway, so we know that we have 49 pi is the area of the circle, and we need to find the area of that hexagon. We also know that the total area, we're going to divide by that, and that's just the circle, so that's just, again, 49 pi. So this is the shape we need to work on. We need to find the area of this hexagon. And it is a regular hexagon, so that means there are 6 congruent isosceles triangles in there. And each one of those isosceles triangles has a degree measure right here of 60 degrees. So the formula for that is the area is equal to 1/2 the apothem, which I don't know, times the perimeter, which I also don't know. So those are the things I need to find. What do I know? Well, I know that I can find this apothem right here using that smaller triangle. So I'm going to draw it out here. And what I have here is that apothem bisects that angle, so that's going to be 30 degrees. This is your 60. You know that this is 7. So if you want to use your 30, 60, 90 degree triangle ratios, remember that this shorter side is x and the hypotenuse is 2x, and the longer side is x root 3. You could also use trig on this if you prefer. But since this is 7, then I know this is 3.5. And I know the apothem then is 3.5 root 3. So I got my apothem, and actually doing it this way, I actually found part of the perimeter I need. I found just this half. Of course, now I need to multiply it by 2, which makes the whole side length 7. So now my perimeter is 7 times 6. So again, make sure you're practicing the calculations on your calculator, but you should get approximately 0.173 or 17.3%. And I would like you to try this one on your own. I did